Yeah, my name is William. I am a developer advocate. We recently changed the name. We don't like anymore the other one. And data scientist at GitLab. So today I want to make a quick disclaimer. One of the things that I will be sharing today is basically my learnings as a hobbyist, entrepreneur, consultant, data scientist, and all the things that I have been doing since 2017 that in the realm of machine learning. So I don't mean to tell you this is the ultimate solution, this is what works, and the rest of the things. No, this is what I have learned from experience in the field. And so it's very opinionated. And one of the things that I want to highlight is that there are use cases that might apply or not to whatever you are doing that involves MLOps. And also, I am in that process of realizing that I am getting old. And as a millennial getting old, you start thinking, oh, I should have started saving for retirement. Maybe I should invest more. So that's why I said there are lots of things that you have to pay in life. And one of the things I've been paying recently, but gladly, that's a debt that I am happy to pay, is the technical debt of machine learning applications, because there is a lot of glue code working with this. So that's the inspiration for this. I will frame it in these three questions that I like to ask to myself before doing something, which is, why are we doing this? How am I going to do it? And what am I going to use? So this also helps you to break down if what I'm doing or what I'm sharing will apply to your use case, or even the what, if the technology that I am using is something that you can use, because there are regulations that this is one of the things that I've been finding the most in this field, that it's very cool to see those applications, demos, and everything. But now try to put it in a bank, try to put it in anywhere where there is regulation. That's a completely different story. Even just getting the data to start. I had to go recently through a 3-month process of clearance to get access to some data that I needed to use to learn something, because legal had to do something that I didn't want to pay attention. What was it? I just wanted, okay, let me know when I can do this, and then I will load the data set. But yeah, just saying the different things. So another thing that I have learned is that as technologists, we all like to automate things, and we like to say, let's make this thing automated and let's do it like super fast. But sometimes before you do that, you should question, what is the actual process and why do I want to improve it? And in this case, one of the reasons, the why behind this is because in machine learning, especially if you have been doing it for longer, these days it's more abstract. There are a lot of manual steps that you have to do. Therefore, there are many points of failure and tweaks and many things that you have to do. And just yesterday, one of the presentations that I was attending was about the AI Regulation Act. And the speaker was telling me that sometimes they said that this was from our conversation, that in Europe, with all these regulations, we are tampering innovation. But one of the takeaways is that, but maybe if we follow this regulation, we will bring more structure to the experimentations in data science, and eventually the outcome of what we produce will be more useful, because he was showing that there are many research that is useless because they don't follow good practices. Therefore, there is data leakage and more things. So there is a big reason, for me at least, as complementing from what I learned yesterday, of why should I automate many things and I start paying that debt. And where is the main inspiration? So my background is in machine learning, and back in 2017, I was working with chatbots before it was trendy. We were building different customer support chatbots, and I am from Colombia, but I live in the Czech Republic. And it was very interesting because the chatbot had to understand Czech, and I don't speak Czech. I've been trying to learn. And the beauty of what we do is that you can apply layers of abstraction. And I was able to build a chatbot that understands Czech without speaking Czech, because all I cared was, give me words and I will convert it into embeddings, because not even the computer sees words, they just see numbers. And I am going to judge the intent or whatever classification based on some number and metric, not other things. But back then, those chatbots were more simple. But here, when we were working on this, we were doing what is called conversation-driven development. So we were immediately putting something out there in production. Then someone was asking something in a different way, and we realized that the chatbot was failing, so we had to retrain the model using real data that the customers were putting into the chatbot. And when you do something manually many times, you might start wondering, there must be an easier way to do this. And I was almost alone doing this thing. And as I said, my background in machine learning, I said, maybe I should start exploring something else. And then back then when Google had fewer ads, I started Googling. And then I came with it to the term of, DevOps. There is something called DevOps. Apparently, software engineers, they have solved all of these things that for the machine learning or data scientists realm, this is not trivial. This is not something that, yeah, we all know unit testing. No, this is not like that. So the inspiration came that every time that there was a new intent, we had to retrain the model, and that involved lots of manual steps. So I said, I don't want to do that. There must be an easier way. Also, this is very famous, tracking experiments. What we were doing was duplicating the Jupyter notebook, extracting values, and putting them on Excel or something like that. And this thing eventually, if it's painful when you are a solo developer, now imagine when you have to do this at a scale in a company with more people doing the same. So here, this becomes a problem that you say, okay, this is intractable, I need to do something. So in that something, the goal is that what I propose is that we don't necessarily say, let's automate many things and replace part of the job of a data scientist. No, what I wanted to do is how can we augment the data scientist workflow so we start paying in little chunks, start investing now. I've been learning about investment these days. So there is some compound interest at the end of the day, and we start paying that technical debt of the machine learning systems gradually. And at the end of the day, augmenting the data scientist workflow. So there is one thing in life that they say that brings happiness, and it's when you choose the problems that you want to solve. If I impose you a problem, you might not be quite happy with that. But if you say, this is the problem that I want to solve, you have this intrinsic motivation to do it. So I said, these are the 3 problems that I want to solve. I want to reduce the manual steps. I want to have quicker experimentation. We need to share models easier with other data scientists, and I want to incorporate code and metrics review in my workflow. So I start talking about developer workflow, something that software engineers have been familiar since they start in university, I will say. Back then and today, this was already a thing, being GPU poor, that you need to train something and you don't have specialized hardware. And if you have it, can you raise your hand how many of you have tried to configure a machine with NVIDIA drivers and succeeded the first time? Well, it's very hard. And the third is that you need to train and retrain the model quickly, and if possible, in an automated fashion. So those were the 3 problems. Fast forward, many scars, many problems, many reality checks. This was one of the architecture that became a blueprint for the things that I was doing back then in 2017 to 2019, which was discovering open source packages such as DVC, learning Git. Now I work at GitLab, so now you can see how I ended up in GitLab. I didn't know Git back then. Then learning Git and saying, okay, this is some sort of blueprint in which there are 2 things. Git wasn't created for tracking data, only text files, the code. So we need DVC to track for data version control. The concept of having a project, a remote repository, automating the training and testing. So here, if you see this step of build, train, and test, the one in the middle, train, is different because there is also the concept that if when I'm using CI or continuous integration, another concept that has been battle tested and is old, I say, okay, so I can automate that. I will read the data from the data registry that DVC allows me to register, and I will just pull that data, download it in that machine, and that machine is enabled already with a GPU because I am using a SAS GPU that I can automatically allocate by using CI, and this will extract the data, execute my scripts, and train the model, and then use that model as a regular artifact that gets created in a CI automation. And then testing the model. So this was very interesting because in software engineering, if the unit test pass or fail, then you say, good, this will work or not. In machine learning, probably you know this, but the script could be correct, everything can pass, but the model can be biased, can be a bad model, the performance can be bad. So what do we do here? So we need also to automate how can we collaborate around that testing and reviewing not only the code, because to be honest, in data scientist, the other day I was in a party and one guy was asking me, what do you do? And I said, sometimes data science, and he said, that's not real programming. And I was like, okay, that's when I understand why he said that, because many of us work on Jupyter Notebook and you don't necessarily have that strict workflow that you have to follow. But if we don't do something in a certain way, the cost of the problem can be very expensive. So that's one thing to take into account. And then I said, I don't want to do this thing manually, so I want this machine provision for me automatically. And then this is what I was saying about choosing the problem. Sometimes when you see the light at the end of the tunnel, you think that you are coming to a solution, but might be another train that is coming to hit you. When I was doing this thing, then I came to this word of Kubernetes. I was like, okay, what is this thing? Because it looks like it can serve for my purpose. So at this point, I found how Kubernetes can be very helpful when I'm working machine learning applications, because the test can be successful. But you need to try the application. What we have been seeing, have you seen what has happened these days when they deploy these applications and they apparently work, but when people are using them, they start giving results that are really bad? That type of manual testing, that type of users interacting with it, then I found that we can use then more technology that we will deploy the model to some ephemeral environment. People can use it, and people can say, yes, this passes or no the test. And if I click yes, it will continue moving forward in the CD pipeline to eventually make it to a production environment. And automatic deployment if you feel adventurous, or you can add manual steps for this deployment. Fast forward now, when I came to my team, in my current job, we had more data, and we said we need to use machine learning to learn from how our users are using the product, and what can we do to improve the experience. And then this was what I found in 2023. Like, yeah, sure, you want to do all of that and automate it? Just, this is all you have to learn. So now imagine that what I see is that every year there are more things and more hype, more technologies, more things that they are telling you, this is what you need to do this. And then what we say is that I've been an architect, and when I was architect, I remember vendors coming and saying, look, you have to buy this, and then all your problems will be solved. And when you already have an architecture that is working, the golden rule is, if it works, don't touch it. So I don't really want to add a new component just to solve that little problem. So what can we do? We can say, start small. Sometimes it's not a decision. They were saying, no, we are not going to buy anything. You have to automate all these things, and you have to worry what you have. Okay, so so how can we start? So let's start building with what we have, and gradually. So this sounds okay, but then I also realized that these very same problems that I had when I was just working in smaller projects, they come back again, but in another size, other dimension, when you are in a bigger team. And by dimension, I mean that it's also, all these problems are multiplied by the number of data scientists in your team. So everything, with this thing that they said that when things are bad, they can get worse, I saw it here growing. So I said, okay, these are the same problems that we were facing, but I will say that here, the one that is stealing all the show is that we need to improve and have better collaboration. And this better collaboration implies that we need to start doing small investments, to the topic of this conversation, to enjoy compound interest. And this is what we have been doing. We said, let's start small with what we have, meaning DevOps practices and things that are tested with the software engineering or developer workflows, and let's put them into practice in something that we already know how it works. So here, this is a screenshot of something that also yesterday I liked, something that in some presentation, I don't remember, I think it was the keynote, that they were saying that you have to always think, and this is something that we usually don't do, as technologists, the experience of the end user. So when I came to this team, I had the machine learning experience, but also data science experience, but also I was learning DevOps already before the rest of my colleagues. And many of my colleagues, they live and they love working on Jupyter Notebook. This is very hard to tell to a data scientist, stop doing that, you have to refactor your code and make it production ready, and then you can put your model in production. If you don't do that, you can't then, they will never gonna happen if you tell them that. So because I had that empathy, because I also like Jupyter Notebook, but I also understand the importance of refactoring the code and putting it in a production ready script, I said, let's automate, let's use a staging environment as you see here, and use your Jupyter Notebook. You don't have to refactor. You have to make sure that it runs. And the only thing I'm asking you is that we are going to use a standard with a directory, the structure of the directory. And all you have to do is that make sure that in the commit message, you write train, because we want to train a model, and you give me the name of the Jupyter Notebook file. Just do that for me. So you can still use your Jupyter Notebook, but if you do this, there was a rule in the CI that was going to say if a simple regex, if it's a Jupyter notebook and it has this train, it was going to take it and convert it into a script and use GPU. So this we did, and here we start solving at the scale of more people the manual steps. What was the other problem? That when there was a new data scientist and you have to onboard them, everyone brings their own conda and practices and dependencies. We said, no, you have to, in the part of the CI, you will pull an image, that is the image that we are maintaining with all the dependencies that we need, and then you will train following the template that we have for Jupyter Notebook, using this thing in this model with GPU, and then we will notify and generate some metrics in the merge request. So how does this look like? I had here some examples, but I wanted to show you how it looks like. So imagine that I am a data scientist new in the team, and someone tell me that I have to train the model. So here is when things start getting interesting, because we start learning things from software engineering that for many data scientists, this is like discovering fire, including myself. So let's say that if you say, okay, I have to retrain the model, and I have to do whatever, I don't know, change some hyperparameter or something. So here I can use, just for the sake of the illustration, I'm going to use a web IDE, and I'm going to just add a space just to show you what is important about this. So here, in this one, but let me actually show you a better example. You see here we have the notebooks, and we have the train example. So this is what a data scientist will be doing, and this is what they will need to work on. This is what they will need to commit to the repository. So let's say that as a data scientist, you say, okay, now I want to change this from 0 to 5 for whatever reason, because I'm tweaking things. And then here, I have to put the commit message, as I was telling you, and the path. So I am struggling here with one hand writing this thing. Did I put it correctly? Yes. Training example. 1 second. Yesterday there was one guy that he was showing different layouts of keywords. I just remember Jupyter Notebook. So look, this is all that I'm asking the data scientists to do. So then when you go to the MAR, you see that here automatically what is happening. The training is running, and there will be a notification. And this notification, whatever metrics we are training and publishing on artifacts, they will be published here into the MR. And if I open this training stage, you see that it activated a job that is called train commit. And one of the things that is happening is that it's automatically allocating for me a machine that has GPU enabled. So all of this thing that is happening now is training a model that needs GPU automatically. So as a data scientist, what do you think is the main advantage that I have with this? That I don't have to worry about infrastructure. Someone else will automate this for me. And if that someone else is someone that also understands the machine learning process, they will know how to make it easier for me to start focusing on the modeling or data processing or things that are more relevant for a data scientist. So here, this is an automated job, and this will be the experience that someone will have. The difference that I use here a web IDE, but you can do it from your Jupyter instance. One of the most rewarding things is that another colleague, that his background is statistics, he later discovered that we have something called scheduled pipelines. So he said, we don't have to do this. If we want to check model drifting, we can just schedule a pipeline that will run every week or every month, and it will automatically publish the results. So this is how we also start automating the training and retraining of a model and checking if there was a model drift. I already showed you how we could automatically allocate GPU, and I am rushing a bit because I already saw a time alert. And I wanted to show you some different use cases, which this is what I meant, that there are the different scenarios where I have found this useful. So the experimentation one in data science is the one that I just showed you here. The job just finished. And this is the one where you as a data scientist, you want to quickly do things, train a model, and just push, git commit, git push, and send it to a remote, and use this all automatic allocation of hardware and so on. There is another one that is when things start getting more interesting. That is, let's say that you are working with different things that are more trendy today. You are, I don't know, training word embeddings and doing some other things. Here you see that this is a model that is more complex. But the things are similar. You have to build an image, you have to test it, you have to train a model, and in this case, what I'm training is word embeddings. And then you have to review the model. And taking advantage of that integration with cloud-native technologies, one of the things that I was doing is that, if you see here, this is an environment that is ephemeral. This is one integration automated with a Kubernetes cluster that when the pipeline gets to this stage and you click here in View App, it will spin up this ephemeral environment, and here is where people, if they do this more often, they can try different inputs to the model because the unit test it passes. But here I can try, okay, like what you have seen these days, people, the prompt injections and all those things. Here is the stage where by using this, you can catch those errors that they don't appear when you are doing only unit testing. And then similar notification. And here you can see that this is what should appear in the other one. As a data scientist, one of the things that usually slow us down, and that I have seen it in companies of all sizes, is that you say, how is the model performing? And you say, I'm going to send you the Jupyter notebook. And then you send an attachment, and you have to guess what are the dependencies, load the Jupyter notebook, sometimes just to be able to replicate the experiments. And that thing usually doesn't work. Here, you don't have to open code. You just see the results here. And if one of these things doesn't fit whatever you need, so you say, no, I don't accept this. And this doesn't get merged into the code base. And one of the cool things that we have been doing recently, as you see here, is that there is an integration with MLflow. So now every time that we run a job using CI, this job gets logged into something. This is MLflow in the backend, in the model experiments. And now I can see all of the different experiments that I have been running. So you see that 46 minutes ago, I was trying something here. So if I click here, you see that it says that, okay, I ran this job, this is the performance of the model, and this job generated certain artifacts, and if I click here in artifact, you see this is the model with the embeddings that was trained. So as you can see, this is one of the things that now if I want to collaborate with other people and I say, use my model, they can see all the code that generated it, the artifact that was generated. And now it's not me, but it's someone else that says, I need you. This is what I have seen mostly with the real-life customers, and that they said, we are highly regulated, and every prediction that we make, we have to show the code that created this and who approved this change or not. So here, by standing in the shoulder of giants, and by that I mean DevOps, all of these things were solved already. So there is already auditing purposes. There is already this concept of SBOM, the software bill of materials, that we can just tap into that and say, now we can use this for machine learning. Recently, I saw that one of the customers that I was consulting, they changed it. They don't call it SBOM, but MBOM. This is model bill of materials. And how can I do that? And I say, yeah, sure, we can do that already because software engineer already solved it for us. So this machine learning app, the one I show you, and this is another one that I find, how 2 minutes? Is that you probably are familiar with cloud providers that they tell you that they already have a service that it creates an endpoint for you, and that endpoint will serve your model. If you see that, that's completely true. There are many other tools that can do that, but these tools, they don't necessarily have this tight integration with version control. So one of the other experiments or use cases that I have found is that, example, if you are using something like Vertex AI or SageMaker from this other vendor, you can still use DevOps to be the one that orchestrates the vendor. So in this pipeline that you see here, I am not training using my own infrastructure, Kubernetes, but what I'm doing is using CI and CI principles to orchestrate the interaction between my code and data and that provider. So here I am calling the API, and I am training a model using the infrastructure from that cloud provider. And at the end of the day, if in the same fashion, if you want to have that traceability of when this model was created, what was the dependencies and image that use it, you see that from here we have that visibility to say from this pipeline, that model in that cloud provider was trained automatically. So this is one of those things that I've been working on as well. How can we make use of those other technologies and integrate them, because there are different use cases for all flavors and all different requirements. So one of the things is that by using open source and DevOps practices, we have solved problems of how we can collaborate easier by having this display that is friendly for a data scientist or machine engineer. We can have that traceability of the artifacts and dependencies. And recently we are testing another thing in MLOps that is called the model registry, which is, again, taking concepts from software engineering and saying, this artifact that was created, how can I promote it through different environments? I have it in QA, I want it in pre-prod, now I want it in production, we also want to try, and we will try canary deployments. Are you familiar with the concept of canary deployments? So we want to do the same, but with a model, serving traffic at different pods and testing how it is going, and if it's all good, so we just release the full application in the production environment. So as you see, I've been having a lot of fun learning DevOps as a background in data science and machine learning. And I keep seeing that we are just discovering each other and having that empathy of understanding the data science workflow and seeing the value that it brings to adopt DevOps practices. We, at the end of the day, can make our life easier. That was my main motivation when I was working before. And this is one of the architectures that we have running right now in production. This is taking a lot of data, building, retraining. And as you can see here, we are pulling automatically from Snowflake using Python SDKs and saying GitLab runner. So from here, read, now pass it through all this pipeline, and then a merge request that if whatever model the performance is working or not, we merge it or not to production. So all of these things is boosting our productivity, making our life easier, because we don't care about GPUs, not having GPUs in this, or not being able to, not having the NVIDIA. We are just using SAS runners automatically allocated here. And putting all together, I wanted to say that beware when someone tells you that all you need is this, that with this platform you solve all the problems. There are no shortcuts for all these things. My recommendation is that you start small with what you have. And putting it, again, what I was saying with the technical debt, is start doing those little things. There are lots of things that people already know, and you can use that transfer learning to slowly start adapting and adopting those workflows into the developer workflows, into machine learning workflows. And one of the things that we have been learning recently from experience is that there is no MLOps without DevSecOps, because I just mentioned auditing, and I didn't even scratch the surface when it comes to security in the code. We have been seeing how, you don't imagine if you pass a SAST scanner on a Jupyter notebook, all the warnings and different security vulnerabilities that it finds. So that's another step. I also didn't touch into monitoring, which is another challenge. But I am confident that we will continue moving towards how can we use and sit on these DevSecOps practices to end up building a more robust MLOps practice in our team, because we are starting small with what we know and having a very, 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 very small and soft transition that has in between, has as a center the data scientists and what we need to, at the end of the day, deliver results. So thank you so much, and I am open for questions, and I will spend the rest of the day here if you want to chat more.
Thank you so much, William. We have a couple of questions on Slido. The first one is, how dangerous is it to rely on Jupyter Notebook? Can it be that the training result on the notebook trained remotely is different than the one you get locally?
Yeah, that's totally. But this is the beauty of this. Like, it can be very dangerous. I'm not gonna lie. But if you have it here, like in this pipeline, and you see the results, at least in this pipeline, you catch something, you don't let it pass to production. So you catch it earlier. That's one thing. And with this that I was showing, by using these cloud native components, you are reducing the likelihood that the thing that you are seeing in testing will be the closest as possible to production. It's not perfect, but it's better than just relying on the results that you get in your notebook or in your local machine.
Then another question is it not easier to educate the data scientists rather than building around some bad habits you might have?
Yeah, try. we tried that. We tried that, and yes, but you know, this is about yesterday in the keynote. That keynote was really touching. Someone was saying that when they were the educators, like how you empower people and how do you teach something. I have seen it. I have seen that they say, no, if you want this, you have to refactor. And that usually will not fly. You are dealing with people. People have emotions. But if you say these things that are little tweaks, you still stay a little bit in your comfort zone, but slowly move. the success story with this is that the data scientists in the different teams that I belong, they start expressing interest, they see the value, so I don't have to sell anything, I don't have to impose anything, they just see the value saying, if we adopt this, this is actually making my life easier. So that's how I am, not me, that is how learning this is, that education is happening, but not the one that is imposed to do this. And to be honest, I always like to remember some manager that I had. This is not like we are doing open heart surgery here. The people will die if we fail. Most of these models, many of them are batch processing and bulk predictions. I mean, if it fails, okay, we catch it here. The cost of the problem is something that you need to consider. Once I was working with the police, and they were saying, half an hour of this, and we cannot process some criminal. So that is a very costly problem. That you don't want to fool around. But these things where we are running predictions of historical data, is the cost of the problem versus let's start paying this debt slowly. Yeah, I always think like that in what is the cost of the problem, what are we trying to solve? But that is an excellent question, and I will say that question goes beyond the realm of technical experience. It's most how is it dealing with people, which I'm not qualified to go deeper in there.
Thanks a lot, William.
Thank you.